Good morning students. We had successfully completed the first term portions. So now I start the second term portion. Okay. The second term portion is I start from lesson unit 3. Okay. So the unit 3 is pressure in fluids. Okay. Pressure in fluids. Already you learn in the pressure in the lower classes. What is called pressure? Pressure is nothing but force will be acting in a unit area. Force it will be acting per area. Okay. Fluids means which liquid or gas or anything it will be flow, it will be called as fluids. So anything you can you did flow, anything that are called fluids. Okay. Idella flow agudhu fluids. So pressure in fluids means the pressure it will be acting in fluids, that is will be discussed in this session. So first, what is called pressure? First, pressure in solids. Solids means pressure in solids means we take one paper, we taking one pencil. The pencil dip is very sharp. The pencil it will be easily put on a hole on the paper because the sharp edge will be having the high pressure. That the pressure will be acting on the paper. The paper it will be easily hold. Okay. So the pressure in solids means force. What's the force value? It will be pressure is equal to force per acting area. Okay. Force it will be acting the smaller area, the force it will be greater. The force it will be acting the larger area, pressure it will be decreases. Okay. So force it will be acting a unit area or unit area kammiya idhula irukko anga pressure it will be high. Area it will be high, the pressure it will be low. So this is the formula for pressure. Pressure is equal to force by force by area, and force is Newton and area is meter square. So the pressure unit is Newton per meter square, Newton meter per minus 2, and then pressure, the unit of pressure is also Pascal. It will be given by the owner of MLS Pascal. Pascal is a scientist. It will be who did explain that pressure definition. So the unit of pressure is also Newton per meter square, Newton meter per minus 2, or Pascal, or bar. Okay, Pascal. Okay. So Pascal is a scientist name. Okay. Okay, that is the normal pressure in solids. Pressure is equal to forces will be acting per unit area, and force unit is Newton and area is meter square. So Newton meter per minus 2 or Pascal. Okay. So then examples for pressure in solids, pushing a pin into the board. Pushing a pin into the board, the pin will be having the sharp edge, it will be easily inserted on the board. Suppose the head part you have to try to insert on the board, it will be, is it possible or not? No, because the head portion it will be the blunt one. The blunt one does not insert on the board. Okay. So this is the first one, and second is stand on loose sand. Stand on loose sand means you have to stand on the loose sand. The sand it will be loose. You have to stand on the sand. Your feet or foot it will be easily immersed on the sand because it will be the loosening particles. Does not be the strong particle. So the area it will be loosened. The area type it will be loosened. So easily the pressure it will be exerted on the sand. So the pressure will be high. So easily your feet it will be inserted on the sand. And then third one is stand on a nail bed. Suppose you have to injured by any sharp nail, the pain it will be heavy. Otherwise, you have to make the many nails. It will be insert many nails lying on one bed. You have to keep on your feet on the various number of nails on bed. Does not be hurt because the area it will be increased. ஒரு நெயில் ஒரு ஆணியை வச்சு நீங்கள் உங்களோட ஃபீட்டை குத்துனீங்க அப்படின்னா ரொம்ப பெயின்ஃபுல்லாக இருக்கும். அதே இது ஆணி படுக்கையில் படுக்கிறாங்க, ஆணி பெட்டில் நிற்கிறாங்க அந்த மாதிரி அப்படின்னா because the area it will be broad, that the time the nail it will be various many number of nails is on the bed. So that the nails will be giving the various area surface. That the area surface it will be increases, the pressure it will be reduces. Automatically the pressure it will be reduces, does not be hurt on your body or our feet. So that's the way we does not hurt from the nail bed or anything, but single nail will be giving the greater pressure on our feet or anything. So it will definitely it will be painful. Okay. Then pressure in liquids. Now I explain the pressure in liquids. Pressure in liquids, first you should know about what is thrust. Thrust means the force it will be acting on a perpendicular to the surface. One force it will be acting perpendicularly to the liquid surface, perpendicular to the solid surface, it will be called as thrust. Okay, this is the force. Okay, the force, the pressure, it will be acting, the force it will be acting perpendicularly to the liquid surface, that will be called as thrust. Okay, so thrust means force will be acting perpendicularly to the liquid surface, that is called thrust. So thrust is equal to, example for the thrust, example for pressure in liquids is, you have to take air filled balloon. It will be try to the balloon, it will be instead on the water container. You are taking one container, you are taking the air filled balloon. Okay, the container having water. You try to the air filled balloon to immerse into the water surface, does not do that, because the air balloon will be the white light and water it will be giving the opposite force on the balloon. The balloon it will be moving upward, that is called pressure. The liquid it will be definitely applied to the pressure on the balloon. So the balloon will be floating on the water surface, because the balloon white it will be very much less than the water white. So water it will be giving the pressure on the balloon. Okay, this is the first example. And second example is, we are taking one transparent glass tubes. Okay, we attach one balloon at the end, one end of the glass tube, and we have to pour some water or pour some air. It will be flow some air with the pipe or pour some water on the pipe. The water it will be rushed into the bottom of the container, at bottom of the tube. The balloon it will be bulged, because the water it will be giving the pressure on the balloon to be bulged. So the pressure at the bottom side will be increases. The transparent pipe will be having with the plastic balloon. The plastic it will be bulged out by applying the water pressure. Okay, so the transparent plastic with pipe. And then another one, some more and more example is there. So the pressure in liquids by first thrust, and then the pressure in the liquids P is equal to thrust by area. So thrust by area means Newton per meter square, Newton meter per minus 2 or Pascal. That all of the pressure will be acting on the solids. Now we want to calculate the pressure in the liquid column also. Before enter that topic, what are the factors that will be affect the pressure will be acting on the liquid? So one pressure will be acting on the liquid. What are the factors definitely will be affect the pressure on the liquid? First, depth and density and acceleration due to gravity. Depth increases, the liquid pressure it will be increases. So we are taking one container filled with water, we are putting 3 holes on the sides of the container, so walls of the container. The water it will be rushed in 3 holes, but height it will be vary, the flow direction also vary, the flow motion also vary. So the bottom hole, the pressure it will be high, because the pressure it will be increases due to the depth. Depth increases, the pressure it will be increases. So bottom side la pressure வந்து அதிகமாகி டிஸ்டன்ஸ்ல போய் விடும், அதுக்கு கொஞ்சம் மேலே பக்கத்தில் போய் விடும், அதுக்கு கொஞ்சம் மேலே இன்னும் கொஞ்சம் பக்கத்தில் போய் விடும். So the pressure it will be increases with the depth. So the liquid pressure, 3 holes you have to put, the last hole having the high pressure than the first hole. Okay, so the depth increases and pressure it will be increases. Okay, this is the first factor. And second one, density. What's the meaning of the density? Liquids, all the liquids are having different density. Water having one density and oil having one density. We are taking one container, the container with water, the water having one density, that the density, the water will be having the less density comparable to the oil. So the water it will be flowing to the pressure it will be in water, it will be high comparable to the oil. So easily flow to the another one part. One hole it will be put on the container, that the hole, the water it will be easily rushed out, because the pressure in the water it will be high comparable to the oil. But you have to take one container, put on a hole, filled with the oil it will be rushed slowly comparable to the water. Water and oil you compare பண்ணும்போது oil விட water ஓட flow தான் அதிகமாக இருக்கும். So that is density increases pressure it will be decreases. So density increases, the pressure will be decreases. And third one, acceleration due to gravity. Acceleration due to gravity means acceleration it will be increases, pressure it will be increases. Is it correct? So acceleration due to gravity it will be varies with the place, not to be increases, and pressure it will be increases. Acceleration due to gravity increase and pressure increase because acceleration due to gravity is varies from place to place. So Earth having some acceleration due to gravity, Moon having some acceleration due to gravity. So the pressure it will be vary with the acceleration due to gravity. The acceleration due to gravity it will be increases and decreases in terms of some places. One place and the inner places the acceleration due to gravity and the vary the pressure vary. Okay. So this is the factors it will be affecting the pressure in the liquid column. Okay. Depth, density and acceleration due to gravity. Depth increases, pressure increases, density increases, pressure decreases, and acceleration due to gravity, pressure also increases. But acceleration due to gravity it will be varies with the time, varies with the place. So the pressure also it will be varies according to their terms. And then last one is pressure due to liquid column. How to calculate the pressure in the liquid column? Okay. How to calculate the pressure in the liquid column? Take one container, filled with water, taking the level, marking the level of one liquid column, that the liquid column are having some liquids. We consider as one part of the liquid column. Okay. The force it will be acting on the liquid, F is equal to weight is equal to m into g, the water of the liquid, weight of the liquid. So W is equal to m into g, mass into acceleration due to gravity, and mass is equal to density into volume. Density is equal to mass per volume. Okay, density is equal to mass per volume. We want mass, so mass is equal to density into volume. Density into volume. Volume is equal to area into height. So what's the area it will be covered, what's the height it will be covered. So area into height it will be called as volume. So volume is equal to A into H. So rho into A into H. We have mass value, so definitely we calculate the force value. So F is equal to m into g. We substitute the m value, that is rho A H and g. Rho A H into g. Rho A H and g. That is the force value. Okay. Now we want pressure. So how to calculate? Pressure P is equal to force by area. Force is rho A H G by area is A. So A cancelled. So pressure P is equal to H rho G. That is the pressure in a liquid column. Pressure P is equal to product of height, density and acceleration due to gravity. So 3 பொறுத்து தான் உங்களுக்கு வந்து vary ஆகும். So acceleration due to gravity increase ஆனா pressure increase ஆகும். Okay. So normally the density it will be increases, the pressure it will be increases, because pressure it will be increases or decreases ma. Density increase ஆனா pressure increase ஆகுமா decrease ஆகுமா. So according to the this theory, the pressure it will be increases, the pressure it will be depends on the density of the liquid. So just it will be mentioned with the not to be increases and decreases. Pressure it will be changed according to the density. Pressure it will be changed according to the height. Pressure it will be directly proportional to the density. Pressure it will be directly proportional to the acceleration due to gravity. So this is the formula for pressure in the liquid column. We have to consider one container is filled with water. We have to consider as one part of the container, that is having the height and area is A, and we easily find out the force that will be acting on the water column, that is force is equal to weight is equal to m into g. So we want to calculate the mass. So mass is equal to rho into density is equal to mass per volume. So mass is equal to density into volume. Volume is equal to A into H. So force is equal to, we substitute the m value. So rho A H into g. Substitute the value in pressure formula. Pressure is equal to force by area. So rho A H G by A cancel. So pressure P is equal to H rho G. This is the pressure it will be acting in a liquid column. Okay. So this is the today's session portions. This is the what are the portion we had discussed in this session ma? That is pressure in solids. So what is pressure? What is the definition of pressure? What is the unit of pressure? What's the formula for pressure? What are the examples of pressure in solids? Okay, and then pressure in liquids. What is thrust? What are the examples of pressure in liquids? Air balloon, it will be air filled balloon, it will be trying to immerse on the water surface. The water surface will be giving the pressure on the balloon. The balloon, it will be definitely float on the water. And transparent plastic pipe, we taking the one plastic pipe, we filled with the water, and another one is attached with the one plastic balloon. The water, it will be bulged the balloon. So the balloon, it will be bulged due to the pressure of liquid column. And what are the factors that will be affecting the pressure? That is depth, density and acceleration due to gravity. The pressure will be completely dependent upon the density and height and acceleration due to gravity. And there are all the examples already I gave. And then pressure due to liquid column means we consider one container filled with the water. First to find out the mass and next to find out the force, and substitute the force value in pressure formula and easily find out the pressure is equal to H rho G. Okay. So one problem is there in your book. I explained the first problem in page number 27. A man whose mass is 90 kilograms stands on his feet on the floor. The total area of contact is 2 feet with the floor is 0.036 meter square. How much the pressure exerted by him on the floor? One man having weight is 90 kilogram. Okay. The man, it will be occupy the area as 0.036 meter square. Man occupying area on the floor, that is 0.036 meter square. How much the pressure exerted by him on the floor? That man, what's the pressure will be exerted on the man, sorry, by the man on the floor? That is the asking question. So how to calculate? First we want to find out the force, next we want to calculate the pressure. How to calculate the force? Force F is equal to m into g. Substitute the mass of the man and acceleration due to gravity value. What's the mass of the man? That is 90 kilogram. So F is equal to m into g. Mass of the man is 90 kilogram and g value is 9.8. So 90 kilogram into 9.8. 9.8 we have to consider as 10. Okay. So easily is multiply. So 90 into 10, that is 900 Newton. 900 Newton. That is the force value is 900 Newton. Now we want to calculate the pressure. What's the formula for pressure? Force by area. Substitute the force value, that is 900. Area is 0.03836. 0.036. So we have to divide 900 by 0.036, that is 25,000. So pressure unit is Newton per meter square or Pascal. Okay. So 25,000 Pascal. This is the example. Pascal, it will be just simply mentioned by Pa, Pa, Pa. Okay. And then pressure in gases also. The gases, it will be filled in any one container. The gas molecules will be excess the pressure on the walls of the container. Okay. So the gases also excess the pressure. Okay. That are all called as fluids also. Okay. Then another one example is there. Page number 29. Calculate the pressure exerted by the column of water of height 0.85 meter and aerosol of same height 800 kilogram per meter cube is the density. So how to calculate the pressure? So pressure formula is in liquid column H rho G. First pressure due to the water and pressure due to the aerosol. So how to calculate the pressure due to water? Formula is H rho G. So pressure P is equal to H rho G. The pressure due to one water, H rho water G. H value is 0.85. So height is 0.85 and density of the water is already, and we know that is 1000 and density value is 10. So is easily calculate 8500 Pascal. Okay. And then second one aerosol, water, aerosol. So H rho in aerosol and acceleration due to gravity. Substitute the height value, that is 0.85 and density of the aerosol is 800 and 800 and acceleration due to gravity is 10 meter per second squares. So, we have to multiply all the three values, it is easily get the answer, that is 6800 Pascal. So, what is the value? It will be high ma. The pressure it will be exerted by the resin, it will be greater than the pressure it will be exerted by the water. So, pressure in liquid column formula is simple, that is product of height, density and gravity. So, H rho G, first we apply the H and G H and G value and density of water, we get the one answer, that is 8500 Pascal. And pressure in resin, we substitute the density value for resin and easily multiply the three values, so we get the we get the pressure is exerted by the resin. So, that is 6800. Comparable to the pressure in resin and pressure in water, the pressure in water it will be greater because due to the density. Okay. In the today's session, I explained pressure in liquids, pressure in solids and give the more and more example for the pressure in liquids and solids, and then how to calculate the pressure due to the liquid column and what are the factors are affecting the pressure. Okay, that all are discussed in the today's session and two examples also. Then now the today home assignment is home assignment for today's session. Home assignment for today's session, write the two example problems in your note, write two example problems in your note, in your classwork note. Okay, second one, learn and write pressure in liquid column, pressure due to liquid column, pressure due to a liquid column, pressure due to liquid column. Thank you.